Hello everyone, welcome back to the channel. I am the EE Guru, and this is a continuation video from the previous Kirchhoff's current law video. In this video, we'll be working on 3 example problems. Each example problem has an unknown current that we have to solve for. In the first example problem, we have to solve for I3. In the second example problem, we also have to solve for I3. And in the third example problem, we have to solve for I4. I'm going to give you guys a second to look over the example problem and try to solve it on your own, and then we can work on the problems together. So the first thing we're going to do to solve these problems is we're going to write down the Kirchhoff's current law equation, and then we're going to apply the equation to each example problem and then solve it. So the Kirchhoff's current law equation states that the sum of current going into a node is equal to the sum of current coming out of the node. So this is the equation right here. And we're going to apply this equation to all of the example problems and then solve for the unknown current. So for the first example problem, we have to figure out which current is going into the node and which current is leaving the node or coming out of the node. And we can see that I1 is going into the node. So I1 plus I2 is also going into the node. So we're going to add up I1 and I2, and we're going to set that equal to the current that is leaving the node. In this case, there's only one current that is leaving the node. In this case, it's I3. So now we have our equation for the first problem. We plug in the values for I1 and I2, and we solve for the unknown current. In this case, it will be 3 plus 2 is equal to I3. In this case, I3 will equal to 5 amps. So I3 is equal to 5 amps for the first problem. The second problem, we do the same thing. We write the equation for Kirchhoff's current law, and then we solve for the unknown current. We have to figure out which current is going into the node and which current is leaving the node. So in this case, I1 is going into the node. I2 is also going into the node. I3 is also going into the node. And we have to figure out the current that is leaving the node. And in this case, only one current is leaving the node, which is I4. So what we're going to do is we're going to plug in our values and solve for the unknown current, in this case I3. So I1 is equal to 2, I2 is equal to 5 amps, I3, we don't know the value for I3, so we're just going to keep it to its variable, and I4 is equal to 20 amps. We could rewrite this, 7 plus I3 is equal to 20. We use a little bit of algebra. We subtract 7 from both sides. We get I3 is equal to 13 amps. So that's the answer for problem number 2. And problem number 3, we're going to do the same thing. We're going to write our equation for Kirchhoff's current law, plug in our values, and then solve for the unknown current. So first we have to figure out the currents that is leaving the node and also entering the node. It's hard to see right now, but I4 is actually leaving the node. So this is the arrow. Okay, so let's write our equation. I1 is entering the node. I2 is also entering the node. And the current that is leaving the node are I3 and I4. And now we're going to plug in our values for the current. So we get 2 plus 4 amps is equal to I3, which is equal to 3 amp, plus I4, which we don't know. And we're going to evaluate our equation. We get 6 is equal to 3 plus I4. We use a little bit of algebra to isolate I4. We subtract 3 from both sides, and we get I4 is equal to 3 amps. So that's the video. Don't forget to like and subscribe, and I'll see you guys in the next video.